Question 5. A car has to travel a distance s on a straight road. The car has maximum acceleration a and maximum deceleration b. Starts and ends at rest. Show that if there is a speed limit of v meters per second, the time taken, so we're looking for time, is this guy. We have a v, an a, a b, and an s. Okay, let's do a little diagram here. So we have a speed limit of v. We have acceleration of a, deceleration of b. So we're looking for these times in here, t1, t2, and t3. So if I take t1 first, v is equal to u plus at. v is equal to 0 plus at. So the time taken is v over a, t1. Similarly, we can say that t3 is going to be v over b. So let's look at the distance traveled. The total journey is s. So we're going to have to use that in a minute for in here. But let's look at the distance traveled in these two first. So half the base, which is v over a, by the height, which is v. It's going to give me v squared over 2a. In here, you can see the answer probably already, but a half v over b by v is going to be equal to v squared over 2b. So we can say that the remainder, the distance traveled in, well, let's call it section 1. In 1, distance is equal to s minus the other two, v squared over 2a minus v squared over 2b. And we want time, so we want time t2. So from our distance speed time triangle, time is equal to distance over speed. So this guy here is the distance. So if we divide him by the speed, which is v, we're going to get s divided by v minus v squared over 2a divided by v, which is minus v over 2a. And this is what we're doing here. And v squared divided by 2b is minus v over 2b. And that should help us. So we have our 3 times. So let's add these together. t1, v over a plus v over b. So we have v over a plus v over b plus s over v minus v over 2a minus v over 2b. Now if we just put a number in here, that's a half of v over a and that's a half of v over b. So we have a full v over a here and we're taking away a half of it, so it's going to leave a half of it, or just v over 2a, or 1v over 2a. Similarly with the v over b, we're going to leave 1v over 2b. And you're looking at it as a half of v over b, and then we also have the s over v plus s over v. So that's equal to v over 2a plus v over 2b plus s over v. And hopefully that's what they were looking for. V over 2a plus v over 2b plus s over v. You can see that's what we've gotten down here. So quadrat demonstrandum. Okay, there's a part 2 in this question. Part B, we're asked to show that if there is no speed limit, the time taken is given by this square root of 2s times a plus b over ab. Okay, let's do a little diagram here. So the acceleration of a, deceleration of b. We have max velocity here. We call it v. So this is that ratio question again. If we remember one of the previous ones, where if acceleration is 3 and deceleration is 5, the ratio here, t1 to t2, is 5 to 3. So that means t1 takes 5/8 of the time. So where does this come from? It comes from this number over 5 plus 3, the two numbers added together. So the ratio in this case, T1 to T2, is going to be B, where it was a 5 here, over the two numbers added together is A plus B, to A over A plus B. So then the fraction of the total time taken is B, this is for T1, over A plus B times T. So if we want to get velocity, we're going to need V in terms of these letters to be able to get the area, because we're talking about time here, so we're looking at time, but we're going to be dealing with area because we're told that the total distance covered is S. So if we fill this into V is equal to U plus AT, I think this is the right direction to go in. We get velocity, it starts at 0, and we're going to have A times the time taken in this sector is B times T over A plus B. So the velocity becomes ABT over A plus B. Now this looks a little bit crazy so far. Let's see, are we going in the right direction? Now we know, I'll just come up to the top here so you can see everything. We know that the area is equal to S. So S is equal to half the base, which is the total time, by the perpendicular height, which is this velocity that we've just worked out. ABT divided by A plus B. Now we're trying to solve it down for time. The time is given by, so we just want T. So you can see we're going to have a square root now because we have our T squared here. S is equal to ABT squared over 2 times A plus B. So if I multiply across by 2 times A plus B, I'm going to get 2 times A plus B times S is equal to AB times T squared. And if I divide across by AB, I'm going to get 2 times A plus B times S is equal to, if I divide across by AB, that will be my T squared. So T will be equal to the square root of, is it S? It is 2S, yeah. 2S, these two, times A plus B over AB. Quite a tricky simplification here. Just the ratio, think of these ratios, T1 to T2, and what it entails. Question 6, 3 different parts. Part A, a particle travels starting with initial speed u with uniform acceleration a. Show that the distance covered during the nth second is this guy here, u plus an minus a half of a. Okay, let's look at the distance traveled just with our initial. U is equal to u, a is equal to a, s is equal to ut plus a half at squared. So we'll say that t is equal to n. So s is equal to u n plus a half a by n squared. So that's the distance traveled in n seconds. Now to get the distance traveled during the nth second, so say if this was 10 seconds, we'd have to take away the previous 9 seconds to get the distance traveled just in the 10th second alone. So what is that? That's n minus 1 is the previous amount of seconds regardless of what they are. So now we're looking at a distance, I'll call this S1, where u is equal to u, a is equal to a, and t is equal to n minus 1. So S1 becomes ut, so u times n minus 1 plus a half, just change that into a plus, it doesn't look like a 4, plus a half a by n minus 1 to be squared. So this distance becomes un minus u plus a over 2 times n squared minus 2n plus 1. So to get this distance traveling just this 1 second alone, it's going to have to be s minus s1 in this case. So let's just multiply s1 out. Un minus u plus an squared over 2 minus 2an over 2, so they cancel, minus an, and plus a over 2. So s, we're going to have un plus half an squared, that's s, and we have to have minus s1, so it's going to be minus all of these guys, so minus un. Have we a half an squared? We do. So I've taken in this one and this one, minus a half an squared. They're going to cancel, and that's going to leave me with plus u, and this minus an here is going to become plus an, and we have plus a over 2, which is going to become minus a over 2. So s minus s1 is going to be u plus an minus a over 2. Is that what they were looking for? U plus an minus a half a, u plus an minus a half a. So kind of tricky enough concept is the nth second. So if you think 10 seconds and 9 seconds, you're getting two different distances and taking them away from each other. Part B, we're told that if the particle travels 17 meters in the second of motion, so that's s is equal to 17 when n is equal to 2, and 47 meters, s is equal to 47 meters when n is equal to 7, how far will it go in the 10th? So we're going to need the acceleration and the initial velocity here. So let's look here. S is equal to ut plus a half at squared. So 17 is equal to u. Well, actually, I can use my previous equation. Why don't I just use my previous equation here? So I'm just going to bring this, because this gives us my end. That's what they want us to use here. U plus an minus a half a. So we have these two values. We have s and we have n. So 17 is equal to is equal to u plus so I have my u is 8, a is 6, just come back up here. U is equal to 8, a is equal to 6. So now I have the 10 second of motion. I'm going to get s is going to be equal to u, 8, plus a times n, 6 times 10, minus a half a, so minus a half times 6. So the distance in the 10th second is going to be 8 plus 60 minus 3, 68 minus 3, 65 meters. And in the nth second of motion, that's 10 in the nth second. Let's come to the right a bit. We're going to get the distance is going to be u plus an minus a half a. So in the nth, we're going to get s is equal to 8 plus a 6 times n minus 3, which is going to be 6n plus 5. That's the distance travelled in the nth second of motion. In part C, we're asked during which 2 consecutive seconds will it cover 256. Well, this is going to be n, and the next one will be n plus 1. And that's why we simplified this one down. What do we get? 6n plus 5 is Sn. Sn is equal to 6n plus 5. So Sn plus 1 is going to be 6 times n plus 1 plus 5, which is 6n plus 6 plus 5, 6n plus 11. So when is 6n plus 5 plus 6n plus 11 equal to 256? 12n would have to be equal to 256 minus 16, 240. So n will be equal to 20. So during the 20th and 21st seconds will be the answer to this part. Question 7. A train accelerates from rest to a speed of v. It continues at this constant speed for a certain time and then decelerates uniformly to rest. The average speed for the whole journey is 5/6 of v. To show that 4/5 of the whole journey is covered at a constant speed. Okay, very little information given here, so let's draw our speed time graph. Straight line and back down. So what's going on here? Accelerates to a speed of v. We don't know what the acceleration is here, but we're told the average speed is 5/6 of v. So what is average speed? Average speed we know is the total distance over the total time. So distance over time. So we call our time, let's call them, we could call them T1, T2 and T3, but that would mean putting in 1, 2s and 3s. Let's call them X, Y and Z. So now let's look at, well, we can get the distance. It's going to be a half X times V plus Y times V plus a half Z times V. That's my total distance. My total time is X plus Y plus Z or Z, and that's going to be equal to 5v over 6. The average speed is 5v over 6, yeah, so that's equal to 5v over 6. So we can cross multiply here. 6 by all of these guys over here is going to give me 3vx or 3xv plus 6yv plus 3zv over 5v, and there's going to be a v in everything here, so I'll leave that 5v outside just for a second. 5v times x plus y plus z. So, sorry, I should have wrote equals, not over. It's not over. That's 6 times that is equal to, not underneath it. I hope you all are shouting at YouTube while you're subscribing. 5v times x plus y plus z. So my v's cancel. I'm dividing by v. So I'm going to be left with 3x plus 6y plus 3z is equal to 5x plus 5y plus 5z. Yeah, just let's look at what they were asking us. It's something to do with the 4/5 of the journey is covered at a constant speed. Well, the constant speed is y times v. So we need to show that y times v, that's the journey covered at a constant speed. That's going to be equal to 4 times the other two areas, which is half x times v plus a half z times v. So let's have a look. We can divide by v, so that would mean that y v, I'll just leave the v in for a sec. It's gonna, I can take it out. Let's take the v out. That's going to be y is equal to 4x over 2, 2x plus 2z. So is y equal to 2x plus 2z? That's what we have to show here. So let's leave y on its own. So 6y minus 5y is y is equal to 5x minus 3x. Yeah, it does work out nicely for us. And 5z minus 3z plus 2z. So you can see here that if y, what we've shown here, if that's the case, then 4/5 of the journey, 4/5 of the journey is at constant speed. Question 8. A lift starts from rest and travels with constant acceleration 4 meters per second squared. It then travels with uniform speed and finally comes to rest with constant retardation, also 4 meters per second squared. The total distance travelled is d and the time taken is t. Draw a time speed graph representing the motion of the lift and then show that the time spent travelling at a constant speed is the square root of t squared minus d. Okay, so for 2 4s, we don't know anything about time here. They do tell us v, do they? Uniforms, it doesn't tell us. Okay, we just use a v. We have 3 different motions here. We have 4 meters per second squared. We also have 4 meters per second squared. And we'll call the times again x, y, and z, or a, b, and c, whatever you choose to call them. And now we're asked to show the time spent traveling at a constant speed, and we're told that the distance traveled, the total time taken is t, and the total distance is d. So the area of the tree, you'd say here x is going to be equal to z here because they're both the same speed. And we can also get v in terms of x or z. So v is equal to u plus at. So my velocity is 0 plus 4t. And we've called tx, so v is equal to 4x. If I just sketch this again, maybe a bit better than that. As x and z are equal, I can call this x and x, just to limit my variables. And I have a v here. So we can say that 2x plus y is equal to my time taken. I need to get t into my velocity, so I'm going to get t here. 2x plus y is equal to the time taken. So if I want to get x on its own, 2x is equal to t minus y. So x is equal to t minus y over 2. Now that helped me over here. So that means velocity is equal to, because we need velocity for the areas, it's going to be equal to 4 times t minus y over 2. So my velocity becomes 2 times t minus y. So if I get the areas using this for my velocity, let me just check my question again. Show that the time spent traveling at a constant speed. So time spent traveling, so I'm looking for y, so I need to solve this down into y. So let's have a look here now. Half the 3 areas are equal to d. And what are they looking for? They're looking for t squared minus d. Okay, so the area of the first one, half x by v is equal to a half t minus y over 2 times this guy, 2 times t minus y. That's a half xv. Now this does simplify down. Get rid of those 2 there. And I'm going to get t minus y by itself over 2. Now that's going to be the same as this sector here. So I could say let's double that, multiply that one by 2, and that's equal to just t minus y to be squared. That's those 2 sectors. Now we have y, the middle one, is y times v. So y times 2 times t minus y just gives me 2y by t minus y. So these added together are going to give me my distance. So I can say that t minus y to be squared plus 2y by t minus y is equal to my distance. And we're looking for distance being, we're looking for y in terms of t and d. So we have y, t, and d now. So we're looking for y equals, so let's have a look, t squared minus 2ty plus y squared plus 2ty, excellent, we got some cancellations going on, minus 2y squared is equal to d. So what's that going to leave me with? T squared minus y squared is equal to d. So we're looking for y, so t squared minus d is equal to y squared, which leaves me with y being the square root of t squared minus d. Is that what they were looking for? Yes, y is equal to t square root of t squared minus d. So that's the end of uniform acceleration. Practice all these questions till you become the masters of your own destiny.